You are welcome back. In today's class, we are going to be looking at indicial simultaneous equation. So the word indicial comes from the word indices or exponent or power. We also call it exponential simultaneous equation or initial simultaneous equation. So the knowledge of indices is very, very important in this topic. What we are going to be looking at on this topic is the examples. And the examples are solve the following initial simultaneous equations. And the first question says 27 raised to power x minus y equals to 9 raised to power x over 3. That's the first equation. Then the second equation is 2 raised to power x minus 2y equals to 0.5. So let's take the first example. Number 1. The question is 27 s raised to power s minus y equals to 9 raised to power x all over 3. So let's try to reduce this equation. What we are looking for the linear equation from this indicial equation. And to do that, we have many ways of solving this, but I would like to use this method, which is to cross multiply first. So if I cross multiply, it's going to be 3 multiplied by 27 raised to power x minus y equals to 9 raised to power of x. So the next thing to do is to express 3, 27, and 9 in the same base. And to do that, 3 in base 3 is 3 raised to power of 1 multiplied by 27 in base 3 is 3 raised to power 3 into s minus y. And 9 in base 3 is 3 raised to power 2 raised to power x. So the next thing to do is to open the bracket. We have 3 raised to power 1 multiplied by 3 raised to power 3x minus 3y equals to 3 raised to power 2x. So the next thing to do is to reduce the left hand side to one base. So here we have two bases. So we are going to reduce it to one base, and we are going to make use of multiplication law of indices. So which is 3 raised to power 1 multiplication will change to addition plus 3x minus 3y equals to 3 raised to power of 2x. So since we have the same base, we can cancel out the base and equate the power. So if you equate the power, the equation will become 3x minus 3y, or you can say 1 plus 3x minus 3y equals to 2x. So we now write the equation in the form of straight line equation, which is 3x minus 2x minus 3y equals to minus 1. So this becomes x, that is 3x minus 2x, x minus 3y equals to minus 1. So let me call this equation 1. So the next thing to do is to take the second indicial equation, which is 2 raised to power s minus 2y equals to 0.5. So what we need to do here is to change this decimal number to fraction. So it's going to be 2 raised to power x minus 2y equals to 5 over 10. And 5 over 10 becomes 5 here 1, 5 here 2. That is 1 over 2. And 1 over 2 in index form is the same thing as 2 raised to power minus 1. So we can now equate this and this. That is 2 raised to power x minus 2y equals to 2 raised to power minus 1. So since we have the same base, we can cancel out the base and equate the power. The power will be s minus 2y equals to minus 1. So we got this equation 2. We now bring equation 1 and 2 together and solve them simultaneously. That is s minus 3y equals minus 1 and x minus 2y equals to minus 1. So here I'm using elimination method to solve this. If you consider coefficient of s in equation 1 and 2, we have the same coefficient, which is 1. So we can just check their sign. If they have the same sign, you subtract, but different sign you add. So if you subtract, you equation 2 from equation 1, equation 2 from equation 1. So we have minus, minus. So here we have s minus s, 0, then minus 3y, minus minus, give us, that is minus, minus 2y, equals to minus 1, minus, minus 1. So we have minus 3y plus 2y equals to minus 1 plus 1. So minus 3y plus 2y, that's minus y, equals to 0. So therefore, y equals to 0. So the value of y is equal to 0. So let's look for the value of x. You can also put y equals to 0 in equation 1 or equation 2. So you can put it in any of the equations. And equation 1. So equation 1 is x minus 3y equals minus 1. So when y is 0, we have s minus 3 into 0 equals to minus 1. Therefore, s minus 0 equals to minus 1. S equals to minus 1. So these are the values of x and y. So x is equals to minus 1 and y equals to 0. So you can even check from the equations given whether your answer is going to be true. So that is that for question number 1. Example number 2 says 27 raised to the power of x all over 81 raised to the power s plus 2y equals to 9. While the second equation is s plus 4y equals to 0. So if you check the first equation, it's an indicial equation, while the second equation is just a linear equation. So we are going to reduce the first equation, that is the initial equation, to form linear equation. And to do that, the solution to question 2, we have 27 raised to the power x all over 81 raised to the power s plus 2y equals to 9. So now to reduce this is by making them, to make their bases form the same base. So to form the same base. And the same base we are going to express 27, 81 is to express them in base 3. And the base 3 of 27 is 3 raised to power 3 raised to power of x, then all over 81, that is 3 raised to power 4. So 3 raised to power 4 into x plus 2y, which is equals to 9 in base 3, that's 3 raised to power of 2. So the next thing to do is to take one out of these two bases. So we have 3 raised to power of 3 times s, that's 3x. So using division law of indices, division will change to subtraction. So minus 4 into s plus 2y equals to 3 raised to power of 2. So if you look at this, we have one base here, one base on the other side. So we can cancel out the base. So if you cancel out the base, you now equate the power. So to equate the power, it's going to be 3x minus, open the bracket here, 4 times x is 4x. Then minus 4 times plus 2y, that's minus 8y equals to 2. So we now have 3x minus 4x, that's minus x minus 8y equals to 2. So we can multiply through by minus, so multiply through by minus 1. So we have x plus 8y equals minus 2. So let's call this equation 1. Then equation 2, so this is our linear equation. Then equation 2 is s plus 4y equals 0. So this is equation 2. We can now solve this using either elimination method or substitution method of solving simultaneous equation. So you can say, so let me make use of substitution method. So from equation 2, s equals to minus 4y. So we call this equation 3. And now say put 3 and 1. So if you put 3 in 1, it will be s, equation 1 is s plus 8y equals minus 2. So anywhere you see s, you replace it with minus 4y. So we have minus 4y because s is minus 4y plus 8y equals minus 2. So minus 4y plus 8y, that's 4y equals minus 2. So y divided both sides by 4. So we have 4y over 4 equals minus 2 over 4. So y equals minus 1 over 2. So this is the value of y. That's minus 1 over 2. So to get the value of x, you can just say put y equals to minus 1 over 2 in equation 3. That's to get the value of x. So equation 3 is s equals to minus 4y. So x equals minus 4 into, where y is minus 2, minus 1 over 2. So we have minus 1 over 2. So s equals minus times minus is plus, 4 times 1, 4 all over 2. So s is equals to 2. So it means when s is equals to 2, y is equals to minus half. So that is that on question number 2. So example number 3 says, so we are still on indicial simultaneous equation. So example 3 says 2s inverse, that is 2s raised to the power minus 1 minus 3y raised to the power minus 1 equals 4, and 4s raised to the power minus 1 plus y raised to the power minus 1 equals 1. So you see this question, you can see it's a jump question. And to solve this, we can introduce another constant in solving this type of question, or you can solve it even without making expressing them in linear or using another method. So we have 2s squared, solution to question 3. So 2s inverse minus 3y inverse equals 4. So we can express this as 2 s inverse is 1 over s, so it will be 2 over x minus 3 over y equals 4. So we can call this equation 1. Then the second equation is 4s inverse, that is 4s raised to the power minus 1 plus y raised to the power minus 1 equals 1. So express it in the form of equation 1, that is 4 over x plus 1 over y equals 1, equation 2. So bringing the equation 1 and 2 together, so we have 2 over x minus 3 over y equals 4. So equation 1, then 4 over x plus 1 over y equals 1, equation 2. So from here, I would like to use elimination method from there. And to use elimination method, which means you have to make the coefficient of the one you want to eliminate to be equal. So let's say I want to eliminate y from equation 1 and 2. It means we have to make the coefficient of y in equation 1 and equation 2 to be equal. So what is the coefficient of y in equation 1? 3. I will use it to multiply equation 2 throughout. Then the coefficient of y in equation 1, in equation 2 is 1, so I will use it to multiply equation 1. So here, so I'm using elimination method. 1 times 2 over x, that's 2 over x, then minus 1 times 3 over y, 3 over y, equals to 1 times 4, 4. Then the second equation, 3 times 4 over x, that's 12 over x, plus 3 times 1 over y, 3 over y, equals 3 times 1, 3. So if you look at y from equation 1 and 2 there, we have 3 over y, 3 over y. Now, we are going to consider the sign before them. We have minus plus. So if we have different sign, we are going to add equation 1 and 2 together, or add this and this together. So 2 over s plus 12 over s. So we have 2 over s plus 12 over x. So minus 3 over y plus 3 over y has become 0. So we are left with 4 plus 3. So here we look for the LCM of x and x, which is x. So s in x, 1 times 2, 2, plus s in s1, 1 times 12, 12, which is equals to 7 over 1. So we have 14 over x equals to 7 over 1. If you cross multiply, 7 times x, that's 7x equals to 14 times 1, 14. So divide both sides by 7 by 7. 7 here 1, 7 here 1. So x equals to 7 here 1, 7 14, 2. So s is equals to 2. So that's the value of x. So you can now say put s is equals to 2 in equation 1, or if you like, you can put it in equation 2, so as to get the value of y. So I put it in equation 1. Equation 1 is 2 over x minus 3 over y equals 4 over 1. So when s is 2, so we have 2 over 2 minus 3 over y equals 4. So 2 over 2 is 1 minus 3 over y equals 4. So collect the like term. That is 1 minus 4 equals 3 over y. So 1 minus 4 is minus 3 equals to 3 over y. So if we cross multiply, we have minus 3y equals 3. So divide both sides by minus 3. So we have minus 3y over minus 3 equals to 3 over minus 3. So this called is y equals to minus 1. So therefore, x is equals to 2 and y is equals to minus 1. So on example 3, I've told you we have many ways of solving this type of problem. So the first method I use elimination method. So you can as well use substitution method. So here we have the equation to be 2 s raised to power minus 1 minus 3y raised to power minus 1 equals 4, which becomes 2 over x minus 3 over y equals 4. So we call this equation 1. Then the second equation is 4s inverse plus y inverse equals 1. And it becomes 4 over x plus 1 over y equals 1, which is equation 2. So now we are going to introduce another constant. So you can say let p equals to 1 over x and q equals to 1 over y. So if p is equal to 1 over x, equation 1 will become 2. Equation 1 will become 2p minus 3q equals to 4. So let's call this equation 3. Then equation 2 will become 4p plus q equals to 1. We call this equation 4. So from here, you can use elimination method. So let me eliminate q. So you multiply the coefficient of q in equation 1 and equation 2 to multiply equation 1. So the coefficient of q in equation 2 is 1. So use it to multiply equation 1. The coefficient of q in equation 1, which is 3, use it to multiply equation 2. So we have 1 times 2p, that's 2p, minus 3q equals 4. Then the second equation is 12p plus 3q equals 3. So the next thing to do is to consider the sign. If you have different sign as minus plus, we are going to add. So 2p plus 12p, that is 14p equals 7. So p equals to 7 over 14, which is 1 over 2. So this is the value of p. So from here, we can just get our s. From the left, p equals to what? 1 over s. You know, p equals to 1 over x, and p is the same thing as 1 over 2. So comparing this and this, so it means s equals to 2. So if you compare this with the answer gotten from the first method, you can see we have the same value for x. Then to get our q, can now say put p equals to 1 over 2 in equation, let's say equation 2. And what is equation 2? 4p plus q equals to 1. And when p is half, we have 4 into half plus q equals to 1. So 4 times, that's 2 here, 1, 2 here, 2. So we have 2 plus q equals 1. So q equals 1 minus 2, which is minus 1. So when q is minus 1, we let q to be what? Since q equals 1 over y, and q is also the same as minus 1 over 1, minus 1. And minus 1 is 1 minus 1 over 1. So if you compare these two, cross multiply, y times minus 1 minus y equals 1 times 1, 1. So divide both sides by minus, or transfer the minus to the other side. So y will be equals to minus 1. So therefore, s equals 2 and y equals minus 1. So that is that. So if you compare the two answers, you can see value of s from the first method, which is 2, is equal to the value of s in the second method, and value of y minus 1 minus 1. So thank you.